All right, this is picking up on a concept that we looked at last week sometime. I believe that a few people were missing from class the day that we covered this. So if this part looks familiar, it's because it is for a lot of you, but we will quickly get into parts that are new. So geometric mean of two positive numbers, a and b, is the number x such that a over x equals x over b. So x squared is a times b, and x is the square root of the product of a and b. Means that the geometric mean of two numbers 9 and 4 is 6, because 6 is the square root of 9 times 4. You can think about that 9 times 4 in two different ways. 9 times 4 is 36, so the square root of 36 is 6, or again, you can think about it as 9 and 4 are both perfect squares, so the square root of 9 is 3, and the square root of 4 is 2. 3 times 2 is 6. We'll look at some more examples of that on one of our next slides. Just a reminder again, an altitude is a segment from a vertex to the line containing the opposite side and perpendicular to the line containing that side. For the most part for us, it's going to look more like this. If we have a triangle, altitude goes from the vertex and is perpendicular to the opposite side. So the theorem we looked at, if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. Just as a note, and I'll try to make it a few times here, if you need to, most of these theorem things are found in your book, or you do have the option of just pausing the video and taking the notes. So I won't necessarily always wait long enough just for you to take the notes. So here, this is something we looked at in those 3 days we looked at as an introduction to Chapter 8, so we can break up into 3 triangles. Those 3 triangles have to be similar because all 3 of them are right triangles. Just to point out very clearly, our third triangle is this big triangle here that I traced very poorly there. So those 3 triangles have to be similar because they have a right angle, each of them, and then the 2 smaller, the red and the green triangle, share angle A, which are exactly the same. The blue and the green share angle B, exactly the same, and therefore by angle, the 2 triangles have to be similar, and then by the transitive property we can say they're all similar. From these similarity statements that we get from that previous slide, we get this geometric mean altitude theorem. Given the altitude drawn to the hypotenuse of a right triangle, it separates the hypotenuse into 2 segments. The length of this altitude is the geometric mean between the lengths of these 2 segments, and it creates a very special proportion. This proportion here, x over h equals h over y, which is a geometric mean. So because h is happening twice, it's a geometric mean. We have another geometric mean, which is the geometric mean for the legs. Again, this comes because the triangles are similar, therefore they must be proportional for their side lengths. You'll notice that the 2 proportions given, again, the first one uses b twice, the second one uses a twice. And the way I think about this one is by starting with the hypotenuse. So I'll do one of these. We have C, the hypotenuse of the large triangle, over B, the hypotenuse of this smaller triangle here. That's our first ratio. The second then is B, which is a leg of the large triangle, over X, which is the leg that corresponds in the smaller triangle. All right, So again, we already did these, I think, unless I used a different set of examples last time. So here, this is why simplifying radicals was so important the other day. We have the square root of 3 times 27. Again, the geometric mean between a pair of numbers is the product, the square root of the product, right? So you can look at this two different ways. One would be to say that this is 3 times 27, which is 81. So we have the square root of 81, and the square root of 81 is 9. Or you can break it up, and we have 3 times 3 times 9. The square root of 3 times 3, well, 3 times 3 is 9. There's a square root of 9 times the square root of 9, or the square root of 9 times 9, which again is 9. So it's two different ways to look at the problem. For this one, the first one might make a lot more sense, but actually in general, the second one I think is probably going to be better for us. So our second problem here, again, the geometric mean between two numbers is always the product of the two numbers, the square root of that product. So we have 5 times 15. You could go in and multiply 5 times 15. However, I would suggest instead to just do your prime factorization here. And we get 5 times 3. So the first 5 is the 5 here. And then 5 times 3 is this 15. 5 times 3 is 15. Now you see we have 5 times 5. The square root of 5 times 5 is 5. And we have that 3 left over under the square root. So I would like you to pause now and look at number 3 on your own. I'm going to just continue to do it, so if you don't pause, it's just going to go right into me doing it, but I would much rather you actually take a look at it on your own first. So take your time, pause the video, do the problem, and then come back and watch me do it. So again, hopefully we are able to set up this problem. We have 6 times 2. 6 is 3 times 2. And then we have that times 2 still. We have 3 times 2 times 2. The square root of 2 times 2 is 2. So hopefully you came up with 2 root 3. Again, hopefully you're recognizing why we spent some time just simplifying radicals. We spent a whole day on it, and we had a quiz on it. Write a similarity statement identifying the 3 similar triangles in the figure. This is something that technically goes back to last chapter, so we should be able to see by angle that there's similarity here. We're just going to go in and figure out what it is. So for the first triangle, my suggestion is to start with the largest of the triangles, so something like triangle TUV. This is going to be similar to, and let's start with this smaller triangle here. Now what I do is I don't necessarily go in order starting with T. Here I will, because both the large triangle and the smaller triangle here have this angle T in common, which means that they are congruent, which means in our similarity statement they come in the same order. The second thing I look for is the right angle. In the large triangle, that right angle is angle U, but in our smaller triangle, it's this angle down here, angle A. So the part that goes with U is A, and in the small triangle, what we have left is U. And then I would do the same thing again using the large triangle and this other triangle here. In this one, they both have a right angle and they both share angle V. So V has to come last. The right angle again in the large triangle is U. In the red triangle, it's A. So where U is in the larger triangle, A must be in this triangle, and we are left with U. So from that, we get triangle TUV, similar to triangle TAU, similar to triangle UAB. Again, I want you to pause the video. If you need to go back and rewatch that, do it. Pause the video until you think that you have the 3 similar triangles for number 5. Once you have them, press unpause, and you will again see me work them out. So hopefully you actually did pause it and worked it out on your own. Again, I would start with the large triangle, triangle JKL. Now remember, if you didn't start with JKL, your other 2 triangles are going to be a little bit off here, which is going to be okay. The same as you might look at the big triangle first, I'm going to start by looking at the small triangle here. So you might have the larger of the 2 triangles in second position here, and that's okay. Just remember that the order is what matters, so it's the parts that go together. So in the large triangle and the small triangle I have outlined, the angle J is exactly the same. In the large triangle, it's angle L that's the right angle. In the smaller triangle, it is M. So M must come last, and in between then must be L. Hopefully I don't run out of room here. Finally, we're going to look at the big triangle compared to the bigger of the interior triangles. Okay, I'm going to run out of room. It's okay if you're laughing at me. All right. So the last triangle then has angle K is in both the large triangle, the biggest triangle, JKL, and this triangle. So those spots have to be in the same spot. So K has to be the middle of the 2. Then we have L as the right angle of the large, but M is the right angle for this one, and the missing letter we have is L. So hopefully you came up with LKM. Again, as long as for JKL and JLM, you have them in the same order, so the J's are in the same spot, the K and L, and the L and the M. Similar with the J and L, K and K, L and M for the last triangle. It's okay if you have a different order, that would be fine. All right, using these 2 theorems, we have the geometric mean leg and the geometric mean altitude theorem. Using the altitude theorem, we can solve for x. That would give us 8 over x equals x over 23. And so we have x squared, x times x, this is just solving a proportion, equals 8 times 23. And you might tell yourself, well, why not multiply the 8 times the 23 and actually find what it is? I usually don't, because it doesn't matter what it is. 23 is a prime number. There's nothing that we can divide out of it. So really all we're looking at is trying to simplify this 8 when we get to our square root. So we're going to take the square root of both sides. We get x is the square root of 8 is 4 times 2. And then we still have that times 23. The square root of 4 is 2. And 2 times 23 is 46. So the answer for x is 2 root 46. Now, solving for y and z are both similar. We do need one more part first, which is this part. That is the hypotenuse of the large triangle. It's 23 plus 8, right, because we're just adding the 2 segments, so we get 31. And let's solve for y first. We have the hypotenuse of the large triangle over the hypotenuse of this triangle, which is y. That equals a leg y of the large triangle over the corresponding leg of the smaller red triangle, which is 8. We get y squared equals 8 times 31. Like above, we're taking the square root of both sides. That 8 is going to break up exactly the same as it did before. It's 4 times 2. 31 again is prime. So we get 2 times the square root of 2 times 31, which is 62. Solving for z is almost exactly the same as that. So we still get 31. We get 31 over z is z over the corresponding part with z is again from this green triangle, and it's 23. Notice that 23 and 31 are both prime numbers, and they are not the same. So this time we are going to multiply them together. So we get z squared is 31 times 23, which is 713. Again, there's nothing that we can do. The only two numbers that we can take out of it are 31 and 23. So if we take the square root of both sides, we are going to say that z is the square root of 713, and we're not going to do anything else with it. We're just going to leave it. So those are our 3 answers. In a second, I'm going to have you do the second one here on your own. The only thing that's different with the second one is that this time it does give us the hypotenuse of the large triangle. It does not give us this length, but we should be able to find that length. It's the hypotenuse minus the part that we know, which is 6. And 25 minus 6 is 19. So that length must be 19. Again, like we've been doing, pause the video, try to solve for x, y, and z. I'm going to solve for x first, so if you want to, in a second, after you solve for x, come and watch the video through x. That might be a good idea to do as well. But pause the video now, at least solve through x, if not all 3 parts, and then I will be on the other side of that pause, waiting to solve it for you. All right, so again, we're going to solve for x first. This is the geometric mean altitude theorem because x, the segment, is the altitude of this large triangle. And again, it's a geometric mean. It's a geometric mean of 19 over the altitude equals x over 6. These are the 2 parts that altitude is breaking. If you have 6 over x equals x over 19, that is perfectly fine as well. It is the same thing. 19 is prime. 6 is 2 times 3. Both are prime. We don't have any numbers repeating each other. So again, like that 713, we get x squared equals what 6 times 19 is, which is 114. The only factors here are 2, 3, and 19. Again, none of them are the same, so when we take the square root, it is simplified already, and so we're going to leave it as x equals the square root of 114. If you haven't solved for y or z yet, again, pause the video again, and then come back to it. If you're already done with it, then just keep watching here. We have the hypotenuse of the large triangle, which is 25, over the hypotenuse of the smaller triangle here, which is y. Y is also a leg of the large triangle. Corresponding side is 6 in that red triangle. We get y squared equals 25 times 6. This time, notice I did not multiply them together because 25 is a perfect square. So when we take the square root of both sides, we get y equals the square root of 25, which is 5. 6 is 2 times 3. There's no repeated numbers in that, so we get 5 root 6. And lastly, solving for z. Z is a lot like solving for y. We get the hypotenuse over z is z over the part that goes with it, which is 19. Cross multiply, we get z squared equals 25 times 19. Again, we have that perfect square 25. So we're going to leave it without multiplying those two numbers together. If you happen to multiply those two numbers together, at least recognize that to get to that, you multiplied 25 times 19. So 25 and 19 are both factors. We get z is 5 root 19, and we are done. All right, two more problems that go a little bit deeper into this concept, though in ways these are actually a little bit easier than the problems we've already done. So first of all, recognize that all of these are right triangles, and so potentially we can use that in our favor. The second would be we don't necessarily always have to use them. So here, 3 is the altitude using the geometric mean altitude theorem. That means that that is the part that goes in these two positions. And then we get a 2 and an x in the other, because those are the two parts that the altitude is breaking our triangle into on that side. So we get 2x equals 9. There's no square here, which makes it a little bit easier, though we will get a decimal of 4.5. Now you could go and solve for y next. I would actually suggest that you solve for z because it's easier. Since x is 4.5 and the other part is 2 plus 4.5 is 6.5. Lastly, to solve for y, you could use a geometric mean with 6.5 and 2. On the other hand, I think that it's probably easier if you recognize that 2 and 3 are legs of a right triangle and y is the hypotenuse. And so we can use the Pythagorean theorem. 2 squared plus 3 squared equals y squared. We get 4 plus 9 is y squared. 4 plus 9 is 13. 13 is a prime number, so we get y is the square root of 13. And we are done with that problem. We've solved for x, y, and z. All right, finally, we have one more problem. Again, pause the video and see if you can figure it out. This one is a tougher one to start with because it uses a few different concepts. So I hope that some of you took the challenge to pause and solve. If not, that's okay too. For this one, there are two probably different ways we could go about solving it. One, we could solve for z first using a right triangle, the right triangle and the Pythagorean theorem. Given that we have hypotenuse of 20 and a leg of 10, we could solve for z using the Pythagorean theorem. Otherwise, we can also use our geometric means and solve for y. That would be hypotenuse is 20 for the large, 10 over y. We'll do that one just to show that it works. We might come back and solve for z the same way that we were just talking about before. So we have 20 over the hypotenuse of the smaller triangle, which is 10, equals 10, which is the leg of the large triangle over its corresponding leg, y. We can simplify. We actually have 2 over 1. We get 2y equals 10. Divide both sides by 2, and y is 5. This, again, like the last one, makes x easy to find. X must be 20 minus y, which is 5. That is 15. And finally, solving for z, I'm just going to suggest that we do solve it using the Pythagorean theorem. Z is one of the legs. 10 is the other leg. And 20 is the hypotenuse. So we have z squared plus 100 equals 400, or z squared equals 300. Take the square root of both sides. Well, 300 is 3 times 100, and the square root of 100 is 10. So z is 10 root 3. Now, depending on how much you paid attention during our days, just introducing chapter 8 would be how much you recognize this grouping of numbers. So 20, 10, and 10 root 3, and what that means about the triangle we have. And the answer, or the comment that I'm looking for, is that if you have a side of 10, and to get to the hypotenuse, you have to multiply by 2. And to get to the short side, you have to multiply by the square root of 3. We are dealing with a 30, 60, 90 triangle where this is 30, getting a little messy here, and this is 60. It's not something I expect you to know yet. In fact, it's actually coming up in a different lesson, but it would be good to notice. That's why we did that stuff first, is just to be able to recognize, which means that, again, all 3 of those triangles in there are 30, 60, 90 triangles. So eventually we'll be able to solve them that way as well. All right, lastly, we have our homework. Yes, I know all of the work that you're doing is at home, but I do need you to actually show me that you can do these things. So page 541, 8 to 22 even, 54 and 66. And these will be due tomorrow. So on Thursday, I expect to see them done by noon. And with that, if you don't post it by noon, I can't give you credit for it. I'll be posting answers, solutions, so you can check your work at home shortly after or at noon, which is why the deadline is there. So at that point, I can't give you full credit if I'm giving all of the answers after that. Again, do it before then, post it. Having anything posted is going to be better than nothing. You will have opportunities, which I'll have explained in a different video, of how you can get help before that time. I'll be available a number of times in order to provide any kind of assistance that you need with any numbers, 8 through 22, even 54, 66 before that. You should make use of those times. Also available through email, and I'll get back to you as best as I can through email, or any other method that we can come up with.